So we are in the subject matter of timer, and this is just to recap on the subject matter of timer. So timer, basically there are 8-bit timers and 16-bit timers, and there are timer 0, 1, 2, 3, 4. So we are actually going to look at timer 0 as one of our first example. So timer 0, timer 1 and timer 3 are 16-bit timers, which means you can also configure it as 8-bit timers as well. Whereas timer 2 and timer 4, they are 8-bit timers. So we looked into the concept of timer via timer 0. So timer 0 is a 16-bit timer, which means it has two special function registers, which are timer 0 high and timer 0 low. Each register can actually hold 8 bits, right? So if total becomes 16. So if you're using the timer 0 as a 16-bit timer, the value that you can accommodate is from 000 until FFFF. And if you convert that value into decimal, that is from 0 until 65,535. So each value is known as count or clock cycle. How many counts? So if you're using it, your timer 0 at 16-bit, which means when you turn on the timer, by default, the content of the timer will be 0. So when you turn on the timer will start to increase one by one until it reaches the maximum value of 65,535, and then it will reset or roll over to 0. Now this action of rolling over or resetting will cause the timer 0 flag to become 1. The same principle applies also if we are using timer 0 as 8-bit timer. If you are using it as 8-bit timer, we only will be using one register, which is timer 0 low, which means you can count values from 0 until 255. Then once it reaches the maximum value, it will roll over, and that will also cause the timer 0 flag to become 1. Any question up to this point? Guys? Thank you. I thought you were somewhere else. So we're going to see an example here. We're going to write a subroutine. Earlier we have written a subroutine using program loops. Now we're going to write a subroutine, but we're going to use timer. So write a subroutine to create a delay of 100 milliseconds, and given the frequency oscillation is 32 megahertz. Now this is the formula that we will be using. 1 over frequency oscillation times 4 times prescaler times the clock cycles required to generate the time delay is equals to time delay. So out of this, we know the frequency oscillation, we know the required time delay. There are two unknowns. One is the prescaler and one is the clock cycles. And when it comes to prescaler, we have seen earlier that the prescaler bit, you can see under the TOCON register, the prescaler bits are 2, 4, 8, 16, 32, 64, 128, and 256. So we also have the values for prescaler, just that we have to use a suitable prescaler value. So how do we know whether that's the right prescale value? So here we did some few examples. We tried to use prescaler 16 and we got 50,000 clock cycles or 50,000 counts. Is this a valid count value? Yes, because when you use it as 16-bit, the maximum value is 65,535. So it is a valid value. But let's say if you use the prescaler 2, you get 400,000, and therefore it is not valid because it is more than 65,535. And we tried the maximum value, which is 256 for the prescaler, we get 3125. So we concluded that we can choose any prescaler value as long as the count value is less than 65,535, which is the maximum value it can hold, the count value that timer 0 can actually hold. So once we have decided, so for this example, we decided to use 16 as the prescale value, and therefore we need 50,000 counts or clock cycles to generate 100 milliseconds. So because we need 50,000 clock cycles, what we're going to do is we're going to find out what is the starting value that need to be loaded into timer 0. The reason is we need to take advantage of this. The timer 0 flag becomes 1. So what we do, 65,535 we minus with 50,000 and you get this value of 15,535. So this is the starting value that we should load into timer 0 low and timer 0 high. Why are we interested in loading the starting value? So that when it finishes 50,000, what happens? It will roll over, right? That's our intention. So what is 15,535 in hex? It is hex 3C AF. 3C you load into timer 0 high and AF you load into timer 0 low. Is that clear? Any question up to this point? So based on this, all these calculations that we have done, now we're going to actually start writing the delay subroutine. So when it comes to subroutine, what are the three components for subroutine? The name, the content, and return. Very good. So let us write this down. So we can give the name as, for example, delay 100 millisecond. So that's the name. And now we need to have the content. So when it comes to the content, we actually need to configure timer 0. So let's go. Okay, so this one is really out. Okay, ignore the format. So we have 7 bits. Look here. Let's say this is the timer 0 conditional register token. So it has 8 bits, so we need to know how to configure this. So let's see one by one. Bit number 7 is timer 0 on. So do we want to on or off the timer? Definitely this one we want it to on. So this is going to be 1. The next bit, bit number 6, timer 0 8 bit. So we want to use a 16 bit or 8 bit. 16 bit. So if you want to use a 16 bit, we have to set it as 0. So 0. Timer 0 source select, which is timer 0 TOCS. Now this one, clock source select, means if you are using it, if you configure it as instruction cycle clock, you are using it as a timer. If you set it 1 transition on timer 0 clock input pin, you are using it as a counter. So what is the difference between timer and counter? Listen carefully. Timer is a timer. So when you turn on the timer, what happens? The content of timer will increase, like how just now we showed, right? From 0, 1, 2, 3, 4, 5. How fast it increases? It depends on the calculation that we have just now, right? We have, it depends on the frequency oscillation. 1 over frequency oscillation, then it times 4. So you get how fast is one increment. So that is when you use the instruction cycle clock, you're using the crystal or using the frequency oscillation. Now the frequency oscillation can be from the crystal or can be from an RC circuit, either way. But when you say transition on timer 0 clock input pin, which means there is one particular pin which is also labeled as /TOCKI pin. To that particular pin, you can actually connect. So let's say microcontroller. You have one pin which is labeled as, but the pin label won't be just that. It have something / something. I don't remember which pin is it. I think it's port B or port D or port C. I can't remember. But this particular pin, you can connect it to a switch. And what happens when each time you press, there's a change of logic, right? That change of logic will cause the value inside timers to be incremented. So each time you press the button, the initial value is 0. Each time you press, it becomes 1. Have you seen the clicker, the digital clicker thing? Sometimes it's for prayers and things like that. So we have the press, it increases by 1. Press again, become 2. Press again, 3. So that is counter. Is that okay? So timer you can use as timer or as counter. But here we want to use as timer or counter? Timer. So what is the value? 0. So this one also 0. Timer 0 source edge select bit. Now this one is only valid if you are doing this, because you want to select the edge, right? So this one is don't care. Actually, for this particular bit is don't care, but we just put it as 0. Because here, this bit number 4 only will be taken into consideration if you write 1 at timer 0 clock source select. If you don't select the transition on timer 0 clock input pin, this particular bit, timer 0 source edge select bit, won't be effective. Is that okay? Any question up to this point? So, as far as we have seen, one thing is confirmed. When we use as timer, the value always will be 1, 0, 0, 0. Confirm. Are you all following? For the upper nibble, I'm telling. 1, 0, 0, 0. Let's see for the lower nibble. PSA, timer 0 prescaler assignment bit. Are we using prescaler in our calculation just now? Why are you looking like this? Are we using prescaler? What is this? Prescaler. So are you using prescaler? Yes. So do we want to assign or not assign? Assign. And here is assign is 0. So this is also 0. And then you see the bit number 2, 1 and 0, they are the prescaler value. Now remember that this won't be given. This description won't be given. So you just have to memorize them. So take note that with 3 bits, 1, 2, 3 bits, right? How many possible combinations you can have? 8. So you have 8 prescaler values. So you write down, this is 0, 1, 2, 3, 4, 5, 6, 7, right? 0, 1, 2, 3, 4, 5, 6, 7. So write down 0, 0, 0, 0, 0, 1, 0, 1, 0, and then write the values 2, 4, 8, 16, double of each. Double of each, so until you get 2, 5, 6. So in this case, what is the prescaler value that we use just now? We use 16, right? So what is the value? 16 is 3. So which means here should be 0, 1, 1. So in other words, okay, I don't know what went wrong. So in other words, these 5 bits, they are fixed, right? It will be 1, 0, 0, 0, 0. That is fixed. So the only thing that you need to determine the value is the prescale value. Are you all following? So depending on what is the prescale value that you choose, the last 3 bits or the first 3 bits that will change. So because we used 3, so we have 0, 1, 1. So what is this in hex? Hex 83. Is that okay? Any question about this point? Sorry. So now coming back to our timer. So the first thing that you should do is you should configure the timer 0. So we're going to move the literal value hex 83 and you're going to move it to top on. So what we're doing here, so we are configuring timer 0. So the only number that will change is this one. This one will depend on prescaler value. The 8 is fixed. So after you have configured timer 0 to turn it on, so what you need to do? So when we say configure timer 0, what are we doing? We turn it on, we set it as 16-bit timer, we select the instruction cycle clock so that it will work as a timer, and then we enable the prescaler. And what else we did? We select the prescale value. So that's what we did under configure timer 0. So when you do this, your timer will start to count. But immediately what you should do next? What do you think we should do next? If we want it to count from the right value, we should load the starting value, right? What is the starting value? 15,535, which is hex 3CAF. So we need to load the starting value. So let us load hex AF. So where do we want to load this? Timer 0 low. And then move literal value 3C. Because 3C is the upper and this is the lower, right? So we want to load it into timer 0 high. Is that okay? So what we are doing here is we are setting the initial value to 15,535 so that it will take 50,000 clock cycles to reset or roll over. So the timer is already on. So, but immediately the next thing you should do is load the starting value so that it will start to count from the starting value. And the rollover will cause what? Timer 0 IF flag to become 1. Any question up to this point? The prescaler value is only those values. Cannot change any other value. This is set 2, 4, 8, 16, 32, 64 is the double of each. Start with 2, then it's double. So the next thing that we should do is what? We have to clear just in case. Just in case if the flag was not cleared before this, we always want to clear the flag. So after you clear the flag, what do you want to do? After clearing the flag, what do you want to do? What are we doing? What we'll be doing next? We'll wait for the flag to become 1. We have to wait. So waiting and continuous checking is what method? Polling method. So we can actually use this instruction: bit test file register skip if set. Earlier for the switches we always used to use skip if clear, right? That is because when you press the switch it becomes clear. And then we want it to skip. Of course here you can do that as well. So we are checking for timer 0 flag bit. So if it's not 1, what you should do? You can wait. You wait. So you're waiting for the interrupt. Waiting for the rollover. We're waiting it to reset 50,000 clock cycles. So once it's 50,000 clock cycles, what happens? It will skip. So when it reaches 50,000 clock cycles, what actually happened? Yes? Of course it resets, but what does that indicate? The timer is? Okay, all fine, but what does it tell you? When flag becomes 1, what does it tell you? Yes? It finishes the 100 millisecond, right? That's what we want to know. So it's just like the indicator. It runs 50,000 clock cycles. 50,000 clock cycle will take 100 milliseconds. When it reaches, the timer flag will become 1 and immediately it will go out. So go out means what should be the next instruction? Return. Then this is your subroutine delay. You have the name, you have the content, and you have the return. So this instruction, this subroutine runs for 100 milliseconds. Now this structure of subroutine using timer is a fixed structure. You will only get like this. What are the only things that can change? This 3, this one can change, this one can change, and this one can change. The others are same, right? There's no way the others will change. It's the same thing. So this is how you do interrupt subroutine. Now take note, we can actually use interrupt in 2 ways. The timer in 2 ways. One is you use the timer to generate delay. The second thing is you're using the timer to also generate interrupt. So in this case, we are not generating interrupt, right? We are not configuring interrupt at all. But what we are doing, we're just checking. When it resets, when it rolls over, we're just checking for the flag. So because we have not configured the interrupt, that's why we are doing polling. That's why we keep on checking for the flag bit. Has it become 1? So this is the general principle of timer. Any question? Make sure if you ask, ask if you don't understand, because this will be your question 4 as well. So how do we actually use this? So how do we use this subroutine? Is, let's say if we have start, then you write some instructions, then you can just call delay 100 millisecond, and of course you have your main program like this. And at the bottom of your main program, you should have that delay 100 millisecond return. Any question after this point? We will use this delay 100 millisecond tomorrow. So half of the class, I'll just show you one demo of blinking LED using this timer. We'll do the simple LED blinking. So what you all can do is, remember in Moodle we have 4 design files, Proteus design files. Copy all those 4. We will use one of it. Yes. Yes. Times with 16.
That one what is set inside the 0x83.
0 hex. Oh, this is 83. Yeah, the 83 configures 16-bit to be your prescaler and turning on the timer. The 50,000, the 50,000 is the number of clock cycles that is required to generate 100 millisecond. So you minus with 65,535 to get the starting value. So when you load the starting value, it will start to count 50,000 before it resets. So from here, this formula, what are the things that we are looking for is this one, the prescale value, because we will use this prescale value. Whatever value that you choose, that will be used to determine the value, this one, the 3. The 3 will be determined using that. Then whatever value answer that you get, 50,000 clock cycle or 50,000 count, that is the value that you will use to find out what is the starting value. Because the next step is you need to load the starting value, right? So when you load the right starting value, from the starting value until it resets, it requires 50,000 clock cycles. So what this equation actually tells you is that with 32 megahertz crystal and with 16-bit prescaler, you will be needing 50,000 count or clock cycles to generate 100 millisecond. That's what it means. Any other question? But here, see, there's another example. Write a subroutine to create a time delay that is equals to 100 millisecond times the content of product L register. So what this example is telling, you create a time delay which is 100 millisecond, and you perform the multiplication with the contents of product L register. So product L is used as the multiplier. So how do we actually do this? Do you understand what the question is telling? It's telling 100 millisecond times the content of product L, which means, let's say if the content of product L is 1, so it becomes 100 millisecond times 1. So totally how many times you do the subroutine? 1 time. If the product L value is 2, so 100 millisecond times 2 will become 200 millisecond. So it's just like a multiplier, or we can see it as a loop counter. So what you have to do here, the entire delay you can actually perform in a loop. You can actually loop it. So what are the modifications that you need to do here if you are including something like that to multiply? Very simple. Before the return line, you can actually include this line. Decrease file register, skip if 0, and decrease product L, stop at F. If it's not 0, you branch repeat. Where should repeat go? Repeat should go back here. Why? Why should it go back there? Yes, set the initial value again, because whenever it rolls over, it becomes 0. So if you want it to count back for another 50,000, you have to load back the initial value. And then you can put return. So this is the small modification that you can do. So how do we write this in the main program? So let's say you have start. Okay, then you have some other things. Now before you call the subroutine, you need to load the value into the product L. So let's say we want to achieve 500 millisecond. So what should be the value loaded inside product L? 5. So how can we do that? Move LW 5 and then move it to product low. And then you call delay 100 millisecond. So when you call this delay 100 millisecond, what will be the content inside the product L already? 5, because you loaded 5 before you call the subroutine, right? So it will run for 100 millisecond times. Then it will skip. It will go to decrease. So what is the content of product L? 5. Now it becomes 4. So as long as it's not 0, it will branch repeat. Repeat means it will go back here, it will load back the starting value, and it will count for another 50,000 times. So which means now it's 200 millisecond times. Then once it reaches the reset, it will skip again, it will decrease. So from 4 becomes 3. Then again it will repeat. So like this, it will go 5 times. The last one, when it might become 0, it will straight away skip and return. So these are the 2 ways that you can actually do a subroutine. Actually, we can say 3 many ways of doing. One is, let's say you have come up with a subroutine of 100 millisecond. It's a fixed 100 millisecond. So let's say for your mini project, which I have yet to give, try to settle it as soon as possible. Let's say you're going to use 100 millisecond time delay, and then 500 millisecond time delay, and then maybe 1 second time delay. So in essence, you can see that all these are nothing but multiplications of 100 milliseconds, right? 100 milliseconds by itself. 500 millisecond is 5 times 100 millisecond. 1 second is 10 times. 10 times. So one way is, okay, for 100 millisecond task, you can just write there call 100 millisecond. For 500 millisecond, there are two ways you can do. One is you can call 5 times. Call. So each time will generate 100. So 5 times you call, total is 500. But that is not the efficient way of doing. So we can use this way, this multiplier. So let's say if you just want the 100 millisecond delay, before you call the delay, you move literal value 1 into product L, and then you call. Then along your main program, you needed 500 millisecond. So what you do, you move literal value 5 into product L, and then you call the same 100 millisecond time delay. And because of the multiplier, it will generate 500. And then in another point in your main program, you needed 1 second time delay. So what you do, what is the value you want to load in product L? 10. And then you call the 100 millisecond time delay. So that's another way. Or another way, no sir, I want to do subroutine for each time delay. I want to have one subroutine for 100 millisecond. I want to have one subroutine for 500. I want to have one subroutine for 1 second. Also can. But you have to recalculate back again. What is the right value to load? What is the starting value and things like that. Is that okay? Any question up to this point? So this is using time delay as, so this is using timer as time delay subroutine.